Hi everyone, welcome to Hamilton Math. This video says determine the following: the sum of the first 5 terms of an arithmetic sequence with a first term of 3 and a common difference of 7. So the first one is an arithmetic sequence. So let's look at what an arithmetic sequence is. Well, it's something that we know it starts with 3 and then the common difference of 7. So the next term is going to be adding 7. The term after that is going to be adding 7 twice to the original term of 3. The term after that is adding 7 3 times. And then the final term, the fifth term, is going to add 7 4 times to that original 3. So we could calculate this fairly easily without any equations or anything because it's just the first 5 terms. So it's 3 plus 10 plus 17 plus 24 plus 31. We add 7 every time and we generate those 5 terms. Adding them together gives us a total of 85. Now that seems all simple, but what if I was to ask you for the first 100 terms of that arithmetic sequence? That's going to take you a lot longer to do. So if there were more than 5 terms, what should we do? So let's have a look at that now. The first thing to notice is that we could set up a general equation for this. It's really saying the a term, that's the starting term, plus the a plus the difference term. The third term is a plus twice the difference term, all the way to the very end when we have a plus the difference term times the n minus 1. So if I have 50 terms, I have 49 difference values I've added to that, for example. So if I write that out like so, that's a sum of a sequence like so. But then if I write that same thing backwards below it, so I'm starting with a plus n minus 1 times d, and then I go to the next term would be n minus 2 times d, the next term would be n minus 3 times d added to the a. If I do that same thing and I add all those together and I line them all up, if I add vertically, and I add the a plus n minus 1 times d, the first 2 terms there, I get 2a plus n minus 1 times d. If I do that with the next 2 sets of brackets that are lined up on top of each other, I get the 2a plus n minus 1 times d again. In fact, I get it every single time I add up these numbers together. And so what we could say is, in general, we have this 2a plus n minus 1 times d. And so we have n of those, so we have n times 2a plus n minus 1 times d. But the problem is that we've actually counted this twice because we've set it out in one order and then we've done it in the reverse order below. We've counted it twice. So in order to account for that, we have to divide it by 2. And so that entire sum is going to be that equation because now we've divided that by 2. So let's use that equation to calculate the sum of the first 5 terms of the arithmetic sequence now, instead of just laying out all the numbers. So we go ahead and we substitute n equals 5. We substitute in as well that a equals 3, so it's 5 times 2 times 3, plus n minus 1, well n is 5, so 5 minus 1 times that difference of 7. So working from inside to outside in the brackets and then using BEDMAS, we get an answer for the sum of the first 5 terms of 85, just as we did the other way. So now let's move on to look at the second part of this question that said the sum of the series from 1/2 minus 3 plus 18 minus something all the way to minus 3,888. The thing to notice here is that we're multiplying each term by -6. And so if we're multiplying each term by -6, that actually means it's a geometric series. And so because it's a geometric series, what we're going to do is we're going to use a formula that we have for that. It's not quite as obvious to derive as the last one. So I'm just going to show that to you because this is a very well accepted formula that is used whenever we calculate the sum of geometric series. So it's n plus 1. So what that means is it's the term past the last term. So if the last term is negative 3,888, that means that n plus 1 is that times -6, which gives me in this case a value of 23,328. So the n plus 1 is that. We subtract the starting term of 1/2, and we divide that by r minus 1. Now r is -6, subtract 1, and you'll notice that this is Sn. We don't know how many terms are in the series, but we do know what the sum is despite that. So we go ahead and we simplify the numerator, we simplify the denominator, we divide those two things, and what we get is a final answer of negative 3,332.5. Now the interesting thing here, as I already said, we have no idea how many terms are in there, but the other interesting thing is that sum is actually smaller than the last term. And the reason for that is because the sign is switching on every term. So the sum is smaller than the biggest term in the series. And so be watching for that. If you want more on sums of series, then check out the video on the left. For more on sequences and series, all the lessons in that unit, check out the video on the right. I've made a complete overview of the entire grade 11 functions course, and if you're in that course, I encourage you to check out all those videos on this YouTube channel and share that with friends, and please like and subscribe. Thanks so much for watching.